We've seen the PMT function in action, but sometimes it's not the PMT that you're trying to calculate. Sometimes you're trying to calculate what the interest rate might be, or should be, or ought to be. Or maybe you're trying to calculate the actual number of payments required. Or maybe you're trying to calculate how much you can borrow based on the other variables. What we're going to have a look at is changing the variables in your formula. Currently, your formula sort of sits like this, where we're working out the monthly payment based on the rate, which we know, how many payments you're going to make, and how much you would like to borrow. In our next three little steps here, we're actually setting the monthly payment, but what we want to work out is what does that mean to the annual interest rate. Now the function to work out the interest rate is equals rate, open brackets, and you'll see that within the brackets, the parameters are effectively all the other parts that we've used previously. So it's the number of payments. Well, that's that cell there, comma. It's the PMT value. Well, that cell there. It's the present value. Well, that's the amount we would like to borrow. We then need to multiply the rate by 12 to make it an annual rate and return. And you'll see we end up with a negative annual interest rate. But the reason really for that is our monthly repayment is below what it should be. So let's push that to 270. And you see that our annual interest rate is then 8.9%. Don't forget that the PMTs are quoted in negative figures, so minus 270, because you're paying that amount out. We can calculate the number of payments. Perhaps we know the other three variables. That equals n per, open brackets, and you'll recognize the other variables we need, which is the rate. Don't forget the divide by 12 because we're now working on monthly rather than the annual rate that we've quoted, comma, the PMT, $300 in this case, comma, the present value, which is the loan amount, and close brackets, the other two parameters being totally optional, and return, and we need to make 60.66 payments. So effectively, the last payment wouldn't be a full payment. If we then altered the repayment and said, well, actually, we can afford to push that to 330, you can see that the other values remain fixed. Because we're now dealing with a formula for the number of payments, it's the number of payments that drops. And the last portion, you might already have the interest rate, the period, and how much you can afford. What you now want to do is work out, well, what does that allow me to borrow? Equals PV, present value. What's our rate? Well, it's there, divided by 12, because that's an annual rate again, comma, the number of payments we wish to make, comma, our PMT, our monthly payment. Close brackets, return, and it calculates you could borrow up to $22,941 based on the other three values being fixed. Well, we can now vary those and say, actually, I can only afford 200. What can I borrow? 11,470.69. So by making use of any of the other three formulas, so that's the PV, the N per, or the rate, you can actually vary the portion of your loan calculation that you wish to have flexible. So it might be that we wish to play around with different monthly repayments and see what we're able to borrow, in which case you would use this little section here. Or it may be that you wish to keep the amount borrowed the same, but vary perhaps the percentage or the monthly repayment and see what difference that makes on the actual number of repayments. So all the parts of your calculation can be fixed, with a certain part being variable, by making use of one of the different formulas within that same little family of formulas. So that's the PMT, the rate, the N per, or the PV.